Dear and beloved students, today we are discussing basics 2 of solar radiation chapter. In this, I am trying to enlighten you on 4 small subheadings: solar spectrum, functions of light, factors affecting solar radiation are received on the earth's surface, and energy balance of the earth. Now, before that, I just would like to tell you a small story. It's only to inspire you. Once there was a farmer. He was a very skilled farmer. He has all the skills to tame any type of animal for his farm purposes, not only for plowing but also for protection, etc., transportation, etc. Once he saw a camel in his village. He was so frightened at the vast size of the camel, he ran away. After a couple of days or 4 days or a week, he coolly observed the gentleness of the camel. So he summoned courage and approached the camel. For a few days, he developed a very good rapport with the camel. It was altogether an animal which was very bold, and it has so much kind on the farmer. It always showed so much of affection towards the farmer. Within 10 to 15 days of approaching the camel by the farmer. After a month, the camel was so kind that when the farmer had gone to him with his son, and when the farmer tried to put a beetle in the mouth of the camel, it opened the mouth, and before asking by the farmer, the camel had gone along with the child, and both were very comfortable. So, what is the moral of the story? Use serves to overcome otherwise dread. Use serves to overcome dread. Now, so let's go into the class. In the first class, I tried to enlighten you on what are the process of transmission of energy, importance of solar radiation croplands, basic radiation laws, solar radiation laws. Now, what is solar spectrum? The radiant energy is transmitted in the form of electromagnetic waves by the sun. The energy from the sun is spread over a very broad band of wavelengths known as solar spectrum. I repeat once again. The energy from the sun is spread over a very broad band of wavelengths known as solar spectrum. Of course, from your examination point of view, also this line is very important. It may come as one of the fill in the blanks. The solar spectrum is also known as electromagnetic spectrum. The spectrum does not constitute only one band, but a combination of different waves which are characterized individually. For example, UV rays, light part, near infrared part, far infrared part, radio waves, microwaves, radar waves, etc. Coming to energy content of different bands in solar spectrum, if the solar spectrum is broadly divided into 3 bands, the first band is UV band. The wavelength of the UV band ranges from 0.005 to zero point 0.4 microns. It has 9% of energy. The second band is a light part, violet, indigo, blue, green, yellow, orange, red. It spreads from 0.40 microns to 0.70 microns, and the percent of energy is 41%. And the third band is infrared band, more than 0.70 wavelength in microns. It has 50% of energy. Now, different bands of the solar spectrum, once again we try to understand. The shorter wavelength of the spectrum are known as ultraviolet rays, UV rays. These are chemically very active. Unless these are filtered in the atmosphere, there is a danger for life on the earth. This band ranges between, as I said a minute back, it ranges between 0.005 to 0.4 microns. In the first chapter of our introductory agrometeorology and climate change, when we were discussing troposphere and stratosphere, I have also mentioned unless the UV rays are filtered by the ozonosphere, there is a danger for life on the earth. Okay, so from the solar spectrum, UV band is a chemically very active band. Now, the second part of the spectrum, which is also known as visible or PAR, photosynthetically active radiation, is also known as light, LIGHT. It is the part of the spectrum which is essential for all the plant processes and ranges from 0.4 to 0.7 microns. The third part of the solar spectrum is the last band, and it is known as infrared band. This is essential for thermal energy of the plant. That means the source of heat to all the crops. This band is more than 0.7 microns. Now, this is in short about the solar spectrum and percentage of energy, the wavelength in microns for UV, light oblique PAR, and the third part, infrared part, which is having thermal energy characteristics. Now, let us go to functions of the light, that is 0.4 to 0.7 microns of the solar spectrum is known as light. The functions of light include all the plant parts are directly or indirectly influenced by light. The light of correct intensity, quality and duration is essential to normal plant development. Poor light availability causes abnormalities and disorders in plants. Light is indispensable to photosynthesis. Light governs the distribution of photosynthesis among different organs of the plants. Light affects tiller production. Light also affects stability, strength and length of kernels. It also affects dry matter production, the size of the leaves, the root development, the flowering and fruiting, and the dormancy of the seed as well. So, these are all the functions of light. That the second band of the solar spectrum ranging between 0.4 to 0.7 microns. Now, the third small subheading for today's class is factors affecting the solar radiation received on the Earth's surface. Factors affecting the solar radiation received on the Earth's surface. That means, if we just go out of this class after our class is over and look at the sky. The sun is there, the earth is there. So from the sun, energy is falling on you, on the ground, on the trees, whatnot. So what are the factors that are affecting the solar radiation received on the Earth's surface? These are broadly divided into two: astronomical factors Geographical factors. What is the importance of astronomical factors? This I am going to explain in three small subheadings. The first one is the solar output. The second one is the distance between the earth and the sun. The third one is the altitude of the sun. In the energy coming from the sun is a function of solar output as far as astronomical factors are concerned. The sun behaves like a black body, so the energy radiated by the sun depends on its temperature in accordance with the Stefan's law or Stefan's-Boltzmann law. Only a tiny fraction of this energy is intercepted by the earth. The reason is that the energy received is inversely proportional to the square of the solar distance, approximately 150 million kilometers. So, the solar output plays an important role as one of the astronomical factors affecting the solar radiation received on the earth surface. The second factor in the astronomical factors is the distance between the earth and the sun. Due to eccentricity of the earth's orbit around the sun, the distance of the earth from the sun changes. Consequently, the receipt of energy on the earth's surface changes, which brings seasonal changes. The third one is the altitude of the sun. The vertical rays of the sun hits the minimum possible area. The greater the sun's altitude, the more concentrated is the radiation intensity per unit area at the surface. Similarly, the receipt of solar energy on a surface normal to the beam is approximately 7% more on 3rd January at the perihelion than 4th July at the aphelion. Okay, so these are the astronomical factors. There are 4 geographical factors. The first one is the effect of atmosphere. The quantity of solar radiation passing to the earth is depleted due to the presence of aerosols. In the first class I told the solid and liquid particles present in the atmosphere are known as aerosols. So, the quantity of solar radiation passing to the earth is depleted due to the presence of these aerosols. That is one of the effects of the atmosphere on the factors affecting the solar radiation received on the earth's surface. The second factor is the effect of the latitude. According to latitude, the amount of solar energy reaching the earth changes because the day length and the distance travelled by inclined sun rays through the atmosphere changes. The third factor under the geographical factors is the effect of aspect and altitude. Similar to point 2, that is effect of latitude, the effect of aspect and altitude is also on the same analogy. A flux of solar radiations received increase with increasing altitude. For example, mountain areas which faces sun rays receives more radiation, while the valley areas may receive less amount. This is the effect of aspect and altitude. Areas facing the sun in the mountains, they receive more radiation, while valley areas face less area, thereby less amount of radiation is received. The final one is the length of the day. As the duration of the day increases, the amount of radiation also increases naturally. The intensity and the day duration together decide the quantity of radiation received. So, Just to sum up the factors affecting the solar radiation received on the Earth's surface: astronomical factors 3, solar output, distance between the Earth and the Sun, altitude of the Sun; geographical factors 4, effect of atmosphere, effect of latitude, effect of aspect and altitude, length of the day. Now let us go to the last part of today's class, that is the energy balance of the Earth's surface. So what is energy? What is its balance? It is very interesting. I explain to you in just a couple of minutes. Energy balance of the Earth. Okay, the solar radiation received from the Sun is referred as energy, energy. Solar radiation received from the Sun is referred as energy in physical parlance or physical technology. And to explain this one, energy balance. One way the energy comes from the Sun passing through the atmosphere. I explained to you a couple of minutes back. This is known as incoming solar radiation. Abbreviated form is insolation, incoming solar radiation. The other way, all the energy that is received must go back passing through the atmosphere. This is known as outgoing solar radiation. So, there is incoming solar radiation, there is outgoing solar radiation. If this is not balanced, the Earth goes on getting warmed up, and the life on the Earth for human beings, animals, crops, whatnot is impossible. So, there should be a total of incoming and outgoing solar radiation over the Earth's surface. It must be zero. This is known as energy balance. That's all. Whatever is coming should go back. The total of incoming and outgoing must be zero. This is known as energy balance of the Earth. Of course, if the incoming solar radiation is 100% or 100 units, about 31 units are immediately reflected back into the space. This reflected back into the space is distributed among clouds, air, dust at 21%, 6% and 4% respectively, making up to 31% immediately reflected back. How much is passing through the atmosphere and reaching the Earth's surface? 69%. So, the remaining 69% hits the Earth and atmosphere. Out of this, 18% is directly absorbed by the ozone, water vapor, etc. 3% by clouds, and only 48% reaches the Earth's surface. Therefore, the Earth gets heated up. The Earth gets heated up. So, once again, I would like to impress upon you, the total of incoming and outgoing solar radiation over the Earth's surface must be 0, 0, 0. This bit will come in the midterm and final exams. The energy balance is simply incoming is equal to outgoing. That's it. However, due to greenhouse effect, a little of energy is trapped in the atmosphere. That makes human life possible. Not enhanced greenhouse effect, normal permissible greenhouse effect. Okay, this is the energy balance of the Earth. The incoming solar radiation insolation is equal to outgoing solar radiation is known as energy balance. The total of incoming and outgoing solar radiation over the Earth's surface must be 0. Okay, may God bless you. Best of luck.